So in this video, we're talking about Module 1, Topic 2, Lesson 5, and this is the second part of this. So by the end of this, you should be able to answer these questions. What method can you use to go from standard form to vertex form with a quadratic function? What are the steps to completing the square? And once your quadratic equation is in vertex form, how can you solve for the roots? So before we get started with that, what I want to do is I want us to talk about radicals because we're going to need to know how to simplify radicals. So radical is any quantity with the radical symbol, what we're used to calling the square root. Its actual name is a radical. So 4 is the coefficient and it's being multiplied by the square root of 10. Okay, 10 is the radicand and it's the number that is inside the house. That word got cut off, okay? And so when we simplify radicals, our goal is to make the radicand as small as possible. Now, it's not always possible, but if it is, we want to. So in this example here, notice that we took the square root of 12 and we broke it into the square root of 4 times the square root of 3 because 4 times 3 is 12. Well, we know the square root of 4 is 2, and then the square root of 3 does not simplify. So what I want you to pay attention to is that we specifically picked the factors 4 and 3 and not 6 and 2 because in order to do this, you must choose a factor that is a perfect square. So I did go ahead and give you a list of the first 15 perfect squares to help you go through this. So how do we solve this? What we do is if we look at our first one where we want to simplify the radical, we want to go ahead and we have the square root of 45. We need to look, where does 45 fall in between all these list of numbers? And it falls right here in the middle. So what we're going to do is we're going to take 45 and we're going to start dividing it by each number. So we're going to start by 36. Our goal is to see, do we get a nice whole number or do we get a decimal? So 45 divided by 36, we get a decimal, so that's not our answer. And you just keep on going. So 45 divided by 25, we get 1.8, so that doesn't divide evenly. So then we go on to the next one, 45 divided by 16. 45 divided by 16, we get a decimal, 2.8, so that's not what we want. Okay, we're looking for a nice, pretty whole number. When I take 45 and I divide it by 9, that gives us 5. So that's the one we want because when we divide, we get a nice whole number right there. So what we can do is we can go ahead and break down the square root of 45 to be the square root of 9 times the square root of 5. 5 times 9 is 45. Well, we all know the square root of 9 is 3, and then 5 cannot be broken down anymore. So we get this right here, and that would be our simplified radical. Okay, we do the same thing for the next one. So the square root of 72, we find where does 72 fall in these list of perfect squares, and it falls right here in between 64 and 81. So we're going to start with 64. So 72 divided by 64 gives us 1.125. So that's not dividing evenly. Then we're going to take 72 divided by 49. And that gives us 1.469. So that's not what we want. So then we take 72 divided by 36, and that gives us 2. So that is the magical one that we want. Okay, so what we can do is we can take 72 and we can break it down into the square root of 36 times the square root of 2. 36 times 2 is 76, or 72. 36 times 2 is 72. So then from here, we know the square root of 36 is 6, and the square root of 2 cannot be simplified anymore, so we get 6 square root of 2. Okay, Looking at the next one, we have the square root of 45 or 42. So if I take 42, that falls between 36 and 49. So we're going to take 42 divided by 36. Okay, that's not going to divide evenly. So then we do 42 divided by 25. That doesn't divide evenly. So then we take 42 divided by 16. That doesn't divide evenly. Then we take 42 divided by 9. That also doesn't divide evenly. And so our last chance, 42 divided by 4, and that doesn't divide evenly. So no perfect square goes into 42. Therefore, this is as simplified as it can get, and sometimes that happens where you can't simplify numbers. Okay, so that's how we simplify radicals. Okay, now we're going to move into reviewing solving by factoring. So first thing we ask ourselves, is there a number or variable that goes into all three of our terms evenly? And the answer is no. So that means we can go ahead and factor. For this one, we do not need slide and divide because our x squared is positive. So our last number goes on top. Our middle number goes on bottom. And so what we want to figure out is what we can multiply to get 12 and add to get 10. Well, to get 12, we can take 1 and 12, but that doesn't add to get 10, so that doesn't work. We could take 2 and 6 to get 12, but those don't add to get us 10. And then we can take 3 and 4 to get 12, but those also don't add to get 10. So no factors of 12 add to get 10. Therefore, this means that this is not factorable. So since it's not factorable, that means we have to use a different method to help us solve. And so the method that we're going to focus on today is going to be completing the square. Okay? You could also use the quadratic formula that was taught in the previous lesson, but for this one, we're going to focus with completing the square. So we have complete the square to determine the roots of x squared plus 10x plus 12. So x squared plus 10x plus 12 equals 0. So our first step to completing the square is we're going to move this 12 to the other side. Okay? Then that gives us x squared plus 10x, and I'm going to leave a little bit of space, and equals negative 12. Now we're going to add in spaces. So our original problem was not factorable, so we're going to make it factorable. So what we do is we're going to take this b term right here, and we're going to cut it in half. When we cut it in half, half of 10 is 5. After we cut it in half, then we are going to square that 5 to get 25. That is our magical number that goes here and here. So now, off to the side, we're going to factor the x squared plus 10x plus 25. So there's no number in front of the x squared, so therefore we can go straight into factoring. 25 is going to go on top. 10 is going to go on bottom. What can we multiply to get 10? Add to get 25. That would be 5 and 5. Multiply to get 25, add to get 10. So this factors into x plus 5 times x plus 5. Now, when you have the same factor twice, you can rewrite it as just x plus 5 squared, so you don't have to write it twice. So that's what this simplifies to. But what I want you to pay attention to is that, one, it has our variable x. Then it has a 5, and our 5 was the half term. So the shortcut to this is use your variable and then your half term. Okay? What this is going to be equal to is whatever you get when you add negative 12 plus 25. And that's going to be 13. Okay? Now, I'm going to detour a second before we solve. If we were to move that 13 to the other side, we would get x plus 5 squared minus 13. And what that gives us is it gives us our vertex form. Okay, so a quick little detour. That is our vertex form. What that means is when you complete the square, you're taking standard form equation into vertex form, and now you can identify your vertex, which is negative 5, negative 13. Okay, now back to solving. Okay, I'm going to finish solving over here, so I'm just going to rewrite the problem. We have x plus 5 squared equal to 13. Now we just solve it using our square root property, so we're going to square root both sides. When we do that, we get x plus 5 is equal to, don't forget your plus or minus. So it's equal to plus or minus the square root of 13. Square root of 13 does not simplify. There's not a perfect square that goes into it. So from here, we would just subtract 5 from both sides. And we get x is equal to a negative 5 plus or minus the square root of 13. So you could write it like that, or you could split it up as x equals negative 5 plus the square root of 13, and x equals negative 5 minus the square root of 13. So either one of these would be acceptable, but we do need to recognize both. So either that or both of these. Okay. So now flipping over the page, complete the square to determine the roots of each equation. So same concept. So let's go through these. First thing we're going to do is we're going to start by subtracting 4 from both sides. That gives us x squared minus 6x equals negative 4. I'm going to go ahead and add in my spaces. So once we do that, we take our b term, we half it. So negative 6 divided by 2 is a negative 3. Once you half it, you square it. So that would be negative 3 squared, which is equal to a 9. 9 is the magical number that goes in both of our blanks. Now our shortcut, we take our variable and then our half term, and we put it in parentheses and square it. Then we can take these two numbers and add them. So negative 4 plus 9 is 5. Now that you have it in that vertex form, you can go ahead and solve. So to solve, we would take the square root of both sides. And so that would give us x minus 3 is equal to plus or minus the square root of 5. From here, to solve for x, we would add 3 to both sides. And we would get x is equal to 3 plus or minus the square root of 5. Now, one thing that I did forget to say is that you could type these in to get decimal approximations. So real quick, let's go back to these first ones where we actually split it up. So in your calculator, you could type in negative 5 plus the square root of 13. And that would give you the decimal approximation of negative 1.394. Then you could do the same thing, negative 5, but minus the square root of 13. And it gives you the decimal approximation of negative 8.606. So you can type these in if you need a decimal approximation of it. If you were to graph these, you would get the decimal form and not the exact form. Okay, so why don't you pause the video and try letter B? Okay, so first thing you should have done on letter B is subtract 6 from both sides. that gives us x squared minus 12x equals a negative 6. Then I will add in the spaces. And so we get, we add in our spaces, then we go ahead and take this middle term and we half it. So that would be negative 12 divided by 2, which is a negative 6. After you half it, you square it. So we're going to take negative 6 squared, which is 36. So we get a 36 here, a 36 here. Then we can go into our shortcut. So we're going to have something in parentheses squared. It's going to be our variable and then our half term. And it's set equal to these two right here when they're added. So negative 6 plus 36 is 30. Okay, from here you can go ahead and solve. Again, if you move that 30 over, it would put it in vertex form. We have x minus 6 is equal to plus or minus the square root of 30. The square root of 30 does not simplify. Okay, and then you would just add 6 to both sides. So we get x is equal to 6 plus the square root of 30. And that would be that. Now, on this last one, I want you to try the factoring quadratic formula and graphing on your own and then check the answers in Google Classroom. Okay, but I am going to go over completing the square because this one is a little bit different. So we have 2x squared plus 4x minus 6. Go ahead and set it equal to 0. So why is this one different? This one is different because now there is a number in front of the x squared. So it adds a little bit of an extra step. So we're still going to start by moving the 6 over to the other side. Okay. And when we do that, we have 2x squared plus 4x equals 6. So go ahead and add in your spaces. Now, here's where the extra step comes in. What we need to do is we need to factor out the greatest common factor of those three numbers. So when we do that, that is a 2, which leaves us with a 2x squared. Oh, not a 2x squared. It leaves us with an x squared plus 2x plus space equals 6 plus space. Now we go about our normal business. We're taking this, we're going to half it. So half of 2 is equal to 1. Then you square that. When you square that, 1 squared is equal to 1. So then we go ahead and we do our shortcut. But I forgot something. So we placed a 1 in this spot, but a 1 does not go here. To get the number that goes here, you actually have to take this 2 times that 1, and so we put a 2 here. Okay, so we do our shortcut, our variable plus our half term, quantity squared. We add these two numbers out here, and that gets us 8. But you also have to remember to drop this 2 down right here. Now, that would be in our vertex form. If we move the 8 over, we can go ahead and solve. So this time to solve, we need to start by dividing 2 first. And so that would give us x plus 1 squared equals 4. Then we can go ahead and square root both sides. And so when we do that, we get x plus 1 equals plus or minus 4. So we do need to split this into two separate equations. So we have x plus 1 equals 4. X plus 1 equals negative 4. To solve, we're going to subtract 1 from both sides. I'm sorry, the square root of 4 is 2. So those 4s should turn into 2s. There we go. So when we subtract 1 from both sides, we get x equals 1. And over here, you also subtract 1 from both sides, and you get x equals a negative 3. Okay? So, again, I want you to try the factoring, quadratic formula, and graphing, and then go check your answers. You should get the same answers for all of them. So if you get 1 and negative 3 when you factor and do the quadratic formula and graph it, then you're doing it correctly. If you have any questions, please make sure you write them down and you ask in class.